Right. Our last line of evidence for evolution is experiments and field observations. So I'm going to show you a couple of these, and so that way you can see how they work as far as supporting the theory of evolution. So the first one is one that we've actually done by accident on golf courses. So I don't know how many of you are familiar with golf courses. I'm sure you've driven past one at some point. But on golf courses, there are three general different types of grass. So there is the rough, and this area is an area that gets mowed very infrequently. I know in the area that I live in, they basically don't mow the rough. Or if they do, they mow it like once a year. In this instance that they were doing the observations, they mowed the rough area once a month. So they went through and mowed down the grass in the rough once a month. The fairway is the central part of the golf course, and that is going to be mowed once a week. And then the putting green is right around the flag, and that gets mowed every other day at this specific golf course that they collected the data at. Now you can see up here, it's the same species of grass that was planted on the entire section, right? So whether it's the rough, the fairway, or the putting green, it was the same species of grass. And what they found after a couple of years is that even though it was the same species of grass, the grass had changed in the three different areas. All right. So on the area with the rough, the grass actually had very slow sexual maturation, meaning it took them a long time to produce seeds. And the area in the rough had the lowest seed production. So those plants made very few seeds. Compared to the putting green, and in the putting green, these plants grew very fast and matured very fast, meaning that they produced their seeds very early. So, they wouldn't have to grow very big before they started producing seeds. And not only that, each plant produced a lot of seeds. Right? And then the fairway was in between. And so hopefully this makes sense. What's going on here to make the biggest difference between the rough and the putting green? So what happened to make the rough or make the putting green have these fast maturing, high seed producing plants versus the rough with the slow maturing, low seed producing plants? And so what was happening is because these putting green plants were getting cut constantly, if you were a plant that didn't mature quickly, you didn't get to reproduce, right? And if you were going to reproduce, you better reproduce as much as you possibly can because you might not get to reproduce again, okay? So the plants weren't thinking this. This is just what ended up happening because of the high number of mowing that was happening on the putting green. All right, this is an experiment that has happened, go back, by accident. So we developed antibiotics in the 1940s. That was the first time when penicillin was used to treat bacterial infections. So back in the 1940s, we would run a test to test the effectiveness of antibiotics. And so that's what you're seeing here in these plates. So here there's a little disc that has penicillin in it. And then you put bacteria on the plate and let them grow. And basically what happened in the 1940s, most of the bacteria would be killed. in this case, Staphylococcus. Same thing is true for things like strep. So these bacteria would be able to grow on the very edge, but this whole region in the middle would be an area of basically, no bacteria here. The bacteria would be killed. Now the kill zone in the central section of time, the kill zone is reduced. And today, if we run the same experiment, next to no bacteria are going to be killed. And this is because we've ended up creating antibiotic-resistant bacteria. And this is because we have been using the antibiotics and not always in the ways that we should be. If you, for example, take your antibiotics and take them until you feel better and then stop, then you're going to end up with bacteria that are resistant, just like the pesticides that were talked about in an earlier lecture. And you're going to end up with a bacterial infection that is now partially resistant to that antibiotic. And so we've ended up creating these resistant bacteria that are resistant to not just penicillin, but we actually have staph bacteria that are resistant to more than one antibiotic. If you've heard of MRSA, it doesn't stand for multiple, it stands for methanicillin, which is another type of antibiotic. But there are strains of Staphylococcus that are multiple resistant to antibiotics because of this process. And then the last one is our fruit fly experiment, right? We can create these kinds of experiments to be able to see these changes in populations over time. All right, and then I have this last question for you. I asked this question at the beginning, so I want to ask it here again at the end. And that is the end of Chapter 10 and Natural Selection.